Hello and welcome to this LearnElectrics video on how to use a multimeter. We've had many requests from electricians, plumbers, DIYers and car mechanics for a video on setting up and testing with a multimeter. So let's get started. I use a pretty average general purpose multimeter, and there are many manufacturers of test meters, but they will all have similar functions. So if your meter is not the same as mine, then do not worry, the same functions will be there somewhere. There are three must-have functions on test meters, and these are voltage, resistance and current, just the same as Ohm's law. Most modern test meters will also have a cable continuity test as well. In this video, we will look at how to test with each of these settings and show you some real examples. First, a word of warning. Electricity hurts. A lot, believe me. Some of the test methods that are shown will involve working with live electricity with all its ever-present dangers. Always work safely and protect yourself and others from the dangers of electric shock. Always isolate and work on a dead circuit wherever possible. If in doubt, stop and seek advice from a competent person. I always say that if you look after your meter and if you learn how to use it properly, then your meter will look after you. I would recommend a protective rubber bumper case and a carry bag to protect it. Also, invest in a good set of quality test leads. Remember, you are going to be holding these leads when they have 230 volts or even 400 volts inside them. The last thing you want is an electric shock from your own test leads. A small point, even though most meters will auto power down after 5 minutes of inactivity, it is a good idea to get into the habit of always turning off your meter after each testing session. We can begin by looking at the selector switch options. Your meter may not be in the same order as mine and may have more options, but these are the basic ones that we need to understand. First is the voltage selections. The V with a wavy line on top is the AC or alternating current setting. We will use this for measuring domestic and industrial installations. The V with two straight lines is for DC or direct current testing, such as we would find with car batteries, radio batteries and power supplies. On my meter, there is an extra range for very low DC voltages, just 300 millivolts. That's less than 1/3 of a volt and would be used for testing, for example, instrumentation circuits and printed circuit boards. But what is the maximum voltage that we can measure? Somewhere on your meter, the front on mine, will be an indication of this. Here it is shown as 600 volts maximum, which is more than enough to cover machinery, domestic installations and most industrial circuits. If you are working with 690 volts industrial circuits, then your meter should have a maximum working voltage of 1000 volts plus. Next is resistance, and this is measured in ohms with the symbol omega or the capital letter R. All materials will have a resistance to the flow of electrical current, but we are interested in those that are designed to allow current to flow, such as copper cables, electric lamps, resistors and other electrical components. There are several ranges of measurement designed into meters, and this meter will auto range and find the best range to display the test results. Other meters will need to be set to the best range by hand, but that is no big deal, it is easily done. Resistances can be from fractions of an ohm to many millions of ohms, and reading the displayed results correctly is so very important. Practice reading resistances when you have the chance. We also have some very good videos on the Resistor Colour Code, and we will leave a link in the description to this video. Some meters allow simple continuity tests to be carried out on electrical cables, or for proving that switches are working and for tracing cables. Sometimes this is called buzzing out or belling the cable because of the buzzing noise that the meter makes when it finds continuity. This meter also has a diode bias check function, and we will look at testing electrical components in depth in a later video. Current or amps testing is next on this meter, and we have the option of AC currents or DC currents. Current or amps tests are the most dangerous tests on a circuit if using a multimeter, as we must break into the circuit. This increases the risk of electric shock to us and the danger of accidentally shorting out adjacent wires. It is also the test that is liable to cause the meter's internal fuses to blow if not set up correctly. Especially with current testing, check what you have connected to and how you have set your meter up before applying the power. These are the two fuses that protect this meter from overcurrents when testing on the amps ranges. The fuses are there to protect the meter. The wrong setting or the wrong test lead position may cause the fuses to blow. Have you got spares? We can now look at continuity in more depth. And it is important to understand just what continuity testing can tell us. The first thing we should do, always, when planning to test something, is to prove that our test meter is functioning correctly and that the test leads are in good order. Visually inspect your meter and leads first and then plug in the test leads, one into the volts and ohms terminal and the other into the common terminal. With the meter set to continuity and the leads connected together, we should get a reading of very close to 0 and the buzzer should sound. This proves that the meter has found a continuous path through the leads. Now, separate the leads and the buzzer should fall silent. The meter reading should show a high reading, OL on my meter, or 1999 on some meters. This is your open circuit reading, your fresh air reading, the meter maximum. This reading shows that there is no connection or that the resistance is very high and unacceptable. All metallic objects and wire will have electrical continuity, even a teaspoon. Continuity simply sends a signal down one test wire and looks to see if the signal is returned along the other. If the signal returns and has not been suppressed too much by the materials that it passes through, then the buzzer will sound. One very useful application is testing fuses. Many fuses cannot be seen through, and this means that you cannot tell by eye if it is blown. The fuse wire, the metallic link inside a blown fuse, will have melted, resulting in a gap between the two ends of the fuse. In this case, the current cannot pass and the circuit is dead. But the fusible link inside a good fuse will be continuous and unbroken, allowing current to flow and the buzzer will sound. Testing is easy. Remove the fuse, set the meter to continuity and connect the two probes to each end of the fuse as shown. A blown fuse will show OL or overload, and again on some meters this may be 1999 or similar, and the buzzer does not sound, whereas a good fuse will show close to 0 ohms and the buzzer should sound. Testing short lengths of cable is just as easy. The continuity of the copper wire can be tested from end to end using the same methods as shown for testing fuses. But how can we test a longer length, one that passes through a wall, so that your test leads cannot reach both ends of the cable? Well, most cables will have at least 2 wires, so use the second wire as a wander lead. Connect the 2 wires together at one end using miniature crocodile clips or a connector block and test at the other end. The test signal now goes down one wire, through the connector block or croc clips, and hopefully returns along the second wire. If the buzzer sounds, congratulations, we have just proved that both wires are continuous. Moving on to voltage testing now. The yellow circle is showing the AC voltage selector. This is for alternating currents and will typically be used for domestic and industrial electricity supplies. The pink box is showing 2 settings for DC voltages, the standard range and a very low range. Typical uses of DC voltages will be in batteries, power supplies and instrumentation and control cabinets. Although AC and DC use different settings of the selector switch, both test leads use the same connection sockets on the meter. Let's test a 230 volt 3-pin socket. This is an AC voltage, and I prefer to use a plug top test socket. It is much easier, it's quicker, and is much safer than removing the socket cover and testing at the back of the socket. The correct test points must be used as shown here, and this is the standard arrangement for this type of socket, always. Having set your meter to the correct range, begin with the test leads in the phase and neutral holes. Make sure the socket is switched on. This is a live test. Between the phase or live and the neutral connection, we should have a nominal voltage of 230 volts. What is this word nominal, and why 230 volts when the meter clearly shows it is nearer to 240 volts? This is a standard way of referring to single phase voltages in the UK. Even though we might measure 240 volts or 238 volts or whatever, we write it on our test certificate as 230 volts nominal, and we do all our calculations based on the same 230 volts. Now move the test probe from the neutral and into the earth. The voltage between phase and earth should also be 230 volts. Now turn the socket switch off. The voltage should drop to almost 0 volts. This proves that the switch has disconnected the power. The switch is working. And lastly, test between neutral and earth. As neutral and earth are the same point electrically back at the supply transformer, you should measure close to 0 volts. There will often be a few fractions of a volt difference between them, and this is normal. Looking at the nominal voltages that we have just measured, we should have the following: 230 volts between phase and neutral and between phase and earth, with 0 volts between neutral and earth. This indicates a correctly wired socket. The polarity, the order of the wires, is correct. An incorrectly wired socket, one with reverse polarity, would still show 230 volts between phase and neutral, which is why your kettle would still work. But phase to earth and neutral to earth have changed places because of the incorrect wiring. We now have 230 volts between neutral and earth, and this is clearly wrong. This is a dangerous situation. People are at risk of electric shock, and the problem needs to be fixed. DC voltages are easily measured using the DC voltage range. If we had a 9-volt battery, for instance, set the range to DC volts and touch each battery terminal with the probes, taking care not to allow the probes to touch each other. As you can see on my probes, they are wrapped in electrical tape so that only the tiniest amount of metal probe is exposed, perhaps just 2 millimeters. And this is to prevent accidental shorting out across the battery. A 1.5 volt battery can be tested in the same way, a little trickier to hold, but it can be done. Moving on to resistance checks now. Choose the ohms range. This meter is auto ranging. Some meters will have 3 or more resistance ranges to choose from. It makes no difference. Practice and use will make it easy to use. Everything will have some resistance. A resistor is made of a mixture of carbon and other materials that are mixed together in known proportions that will give resistors of known values. Some very small resistances and some very big resistances. Here we have a 1 ohm resistor. Simply grip the 2 resistor leads in the 2 meter clips and the result is displayed. Using the same test method, we have here a 47,000 ohm resistor, often called 47K. All resistors have an allowed tolerance, so 46.5K, as displayed here, is within the accepted range for a 47K resistor. And lastly, a 1 megohm resistor, 1 million ohms of resistance. If we write this down, we can write it 1 m ohms, but the M must be a capital M for millions. We can accurately measure cable resistances by selecting the resistance test. Accurate measurement of cable resistance is a requirement for electrical certificate completion. The electrician must record the actual resistance for each cable in a building, and, knowing the resistance of a certain size cable, we can calculate the length of a cable, even through walls and under floorboards. Current measurement, or amps, is an important factor in the electrical and the electronic work. We want enough current to flow to enable work to be done, for the circuit to work, but we need to know that the current flowing is not so great that it is going to damage components or cables. This is my important health and safety bit. Testing current with a multimeter often requires that we have an open contact to live parts. The risk of electric shock is therefore much greater. If you must test current using the following method, then please exercise extreme caution and care. If you are in doubt at any time, then disconnect the power and seek advice from a competent person. For electrical installation work, a clamp meter is a much safer option. Also, if your meter is not set up correctly, then you may blow the test meter's internal fuses. So, imagine that we have two resistors in a circuit and we want to know how much current is flowing through them. How do we proceed? We need to break into the circuit and expose the ends of each resistor. Now we can connect our test meter onto these resistor ends. What we are doing is linking the two resistors together again, but this time the current also passes through the test meter. Because we are opening up the circuit, removing connections or wires, etc., this often means that normally insulated parts need to be exposed for the duration of the test. Let's do a little demonstration. We would like to measure the current that is flowing through the energy efficient lamp that is in this table lamp. I've set this test measurement up in this fashion in order to be able to carry out the test in the safest manner possible. On the left, the incoming phase is fed into a 3-pin plug-top tester. This allows me to put my test probes into the plug-top tester. The phase from the live terminals is fed into the 10 amp connector of the meter, with the meter set to AC amps. The phase then comes out of the meter through the common terminal and into the live connection on a second plug-top tester. Here I am using a double metal-clad socket as a connection point, and now into the spare socket I can plug the table lamp. Neutral is linked directly from the neutral of one plug-top tester into the neutral of the second, and the same with the earth connections. With the lamp turned off, the current flowing is 0 amps, which it should be. Turn the lamp on and current will flow through the circuit, through the meter, through the lamp and return along the neutral. The display shows 0.01 amps of current, which can also be called 10 milliamps, 10 1/1000ths of an amp. An ordinary filament lamp of similar light output would be around 250 milliamps of current, so this energy efficient lamp is about 25 times more efficient. And I hope this little demonstration has shown you one method of how to test amps with a multimeter. And finally, any standard multimeter will measure voltage, resistance and amps. Some will have a continuity test function, basically a low ohms test with a buzzer. But a multimeter is not the same as a multifunction tester. They are different meters for different types of testing. Practice testing with your meter. The more you practice, the better you become. The time to learn is at home or in the workshop, not on the customer's premises. And always be aware of the dangers of electricity when testing. Well, there we are. We hope that you found this video from LearnElectrics to be useful and that it added some more understanding to your electrical knowledge. Testing is a skill that is best learnt by continual practice. Make up tests to give yourself the practice. Every little helps, and it will secure the testing methods into your long-term memory. And get to know your meter. Learn to understand what it is telling you. And good luck with your testing. If you haven't done so already, please click on subscribe below to have access to all of our videos, and please press the notify button to be sure of not missing our next video. Subscribing also helps us too, and we really do appreciate this. Typing in LearnElectrics, all one word, into the YouTube search bar will also give you access to all of our videos at any time. Thank you for watching, and we hope to see you again very soon.